Okay, now that we've learned how to factor higher degree polynomials, we're going to use that skill to help us solve polynomial equations. So we can see here we're dealing with solving an equation now. And if we recall, when we solve any equation, if you recall that the degree of the polynomial represented the number of solutions. So we're going to be looking to write our polynomial in standard form first, and then once we have done that, we can identify the degree of the polynomial, and that way it'll give us an idea of how many solutions we should be looking for. Now, if we look at this first sample problem, what we've got going on here is we've got 14x to the third on the right side. So you recall what we need to do is we need to get everything equal to 0. So this is so we can use the zero product property. And if you remember, the zero product property says that once all your factors are broken down, each one of those, if it's equal to 0, each one of those individual factors can be represented equal to 0. So the first thing we need to do is we need to subtract the 14x to the third from both sides. But pay attention where it shows up in the second step here. Notice it went to the middle, and it went right in between those two. That's because we wanted to write this in standard form. Once we've written it in standard form, then we can start the factoring process. Now, notice we actually have two levels of factoring. So the first thing we do is factor out a common monomial. And then in the second step, we have a difference of squares, and so we have to, in the second step, we have to factor the quadratic, and then even in the third step, we have a difference of squares. So we actually had 3 levels of factoring. So this is important that you catch all of these levels of factoring before you set each term equal to 0. Now, we kind of skipped a step here, but if you see, if you made 2x equal to 0, then x would equal to 0. You can make x squared minus 3 equal to 0, x plus 2 equals 0, and x minus 2 equals 0, and get each one of your terms, or each one of your solutions. So that's 1, 2, 3, 4, and 5 different solutions, which holds true with the degree of the polynomial function. So very important that your solutions match up with your degree. Now, keep this in mind. You could end up with imaginary solutions as well. So you're going to have imaginary solutions and you're going to have real solutions. So don't forget about your imaginary numbers. That is going to be a very important part of this process. Now, let's take a look at the next sample problem that you're going to be working. We've got 2x to the 5th minus 18x equals to 0. So we know that we should have 5 solutions. If you recall, however, if we want to know how many real solutions versus how many imaginary solutions there are, if you remember that when we were dealing with quadratics, our x-intercepts represented the number of real solutions. And so we can actually get a visual of this by graphing this on our calculator. Now remember, if we want to graph this on our calculator, we're actually going to graph f of x equals to 2x to the 5th minus 18x. And recall that this f of x is the same thing as a y value. So over here, the y value is actually equaling 0 in the equation. So let's take a look at that graph. We're going to say 2x raised to the 5th power minus 18x. I'm going to hit enter. We get this graph that looks like this, and you don't see the whole thing here, and we can zoom that out a little bit. So if we want to zoom out just a touch, you can see what that looks like. Now, it's kind of hard to see what we want to look at, but you can see that it's a real sharp curve. It goes up, and down. So you can get a full visual of that. But what we're really looking for here is how many times does it cross the x-axis. So you can see clearly that it hits 1, 2, and 3 times on this particular graph. And that's some valuable information. So we know that we're going to have 5 solutions, but we now know that 3 of them are going to be real solutions and 2 of them are going to be imaginary. And so it's good for us to know that ahead of time, because now we can simply look to make sure that our answers are correct whenever it comes down to that. So what I want you to do right now is use the factoring skills that you learned in previous videos, and then break it down as many times as you can, and then use the zero product property to come up with all your solutions. So go ahead and take a look at that now and give that a try. Okay, if we take a look at this, the first thing that we can do is we have some common monomials here. So 2 is common in both terms and x is common in both terms. So I'm going to say 2x, and that leaves me with x to the 4th, and it actually leaves me with a 9, and of course this is all still equal to 0. Now we need to look at our next level of factoring. The x to the 4th minus 9 is actually a difference of squares, because x to the 4th breaks up into x squared and x squared. 9 breaks up into 3 and 3, so I'm going to say 2x, and I'm going to break this up, and I'm going to remember to carry my 0 down. That's important. So I'm going to have x and x, x squared, and 3 and 3, and then a difference of squares gives me a difference of signs. And at this point I should analyze each term and just make sure that I cannot factor it down any farther. And so if I look at this, x squared minus 3 can't be broken down, neither can the other one. So now I have 3 different factors and they can all equal to 0. So I'm going to make 2x equal to 0, x squared plus 3 equals to 0, and x squared minus 3 equals to 0. And I'm now going to solve each of these individually. So I'm going to divide both sides by 2, which is going to give me x is equal to 0, so that is one of my solutions. Here we have to subtract 3 from both sides, so we get x squared equals negative 3. When I take the square root of both sides, I'm going to have the square root of negative 3. And if we recall, we have the square root of a negative number creates an imaginary number. And keep in mind that when we take the square root of something, it gives us a plus and a minus term. And this is extremely important because we need 2 solutions out of this. So we will then have x equals to plus or minus I times the square root of 3. And so that's 2 more solutions. And then we do the same thing here for the last term. X squared equals to 3. X equals plus or minus the square root of 3. And since there's no perfect square there, we leave it there. And so we can see here, we ended up with 5 total solutions. We have 1, and this is 2 solutions, and this is 2 more, so that's a total of 5. We had 2 imaginary. And then of course we had 2 real here, and 0 is a real number also, so that's 3 real solutions. And that worked out just right. Now let's take a look at our real solutions here for a second. And let's see how our graph worked out. If we were to take square root of 3, what you're really looking at here is a plus or minus 1.73. Now if you look at this in terms of the equation, whenever it equaled to 0, we knew that that gave us a point of 0, 0. And this is going to give us a point of 1.3 and 0. And this is going to give us another point of negative 1.3 and 0. So those are our x-intercepts, and you can see we should have 3 x-intercepts on our graph. And so let's go back and look at our graph a little bit more closely. This time I want to zoom in a little bit closer so we can get a better visual. And you can see here that it's very hard to see where these cross. You can kind of see that that's crossing at the origin of 0, 0, but these, since we had a decimal point or a square root, are a little bit more difficult to see that. So what we're going to do is we're going to use our 0 function on our calculator. That's going to allow us to get these points. And so I'm going to go Menu, I'm going to do Analyze Graph, and I want to take the 0. And if you recall, we just need a lower bound and an upper bound, and you can see that that's one of our zeros, negative 1.73. I can do that for the other zeros as well. So if I do it on either side of that, you can see that we have a 0 there. And then lastly, I can do the final 0 here, and you can see that our 3 intercepts match up with our 3 real solutions. And so that is a good way to know whether you're getting the right real solutions or not, and the right total amount and the correct solutions themselves. So this is a good final problem to get practice on. It's very important that you get some other practice on this and not just working these sample problems in the notes. This isn't nearly enough practice for the depth of these types of problems. So go ahead and get some practice from some resources on Moodle.